Okay, video 3 for Thevenin equivalent circuit. As you can see, RL, which is the load, is in the middle. So once we remove that, so right down here, I'm going to make the Thevenin equivalent circuit. I'm going to put the voltage. We don't know which direction. Then we have ZTH, and then we have the load, which is an inductor. So this load is 800 ohms at an angle of 90. That's the load. We need ZTH, and we need to get VTH. So once we remove the load, we will have it like this. What will you see? I think you're just going to see a regular series circuit. Here. Then we have A, B, we have 600 at an angle of negative 90 here, we have 2K here, and then we have negative plus 10 at an angle of 29. Okay, so basically you just have a regular series circuit, but you need to get the voltage from A to B, which is VTH. So you could start here and go this way, or you could start here and go this way. The first thing we need to do is get E total. Remember, we always start here looking at the sources, so it's negative 10 at an angle of 29, right? Minus 29 at an angle of 10. So when we add them up, we should get 38.59 volts at an angle of 14.84. So that's our what? That's our E total. E total. So what do these two voltage drops have to add up to? 38.59 at that angle. So we could use the voltage divider rule to get these two voltage drops. Okay, so we can use 38.59 at an angle of 14.84 times 2K divided by both of them added together. 600 ohms at an angle of negative 90 plus 2K ohms. And this is to get the voltage across the 2K. So we can put 38.59 at an angle of 14.84. Oop, I put 48. 84. Oh, and this angle 14 too, yeah. Okay, times 2K divided by them added together, 600 at an angle of negative 90 plus 2K. So the voltage across the 2K ohm resistor is 36.96 volts at an angle of 31.54. So that's this one. 36.96 at an angle of 31.54. That's that voltage. Okay? Just for fun, I'm going to get the voltage here as well. All I would have to do with this little handy dandy calculator is just put 600 at an angle of negative 90. So here we would get 11.09 volts at an angle of negative 58.46. That's the voltage across this guy. So now we know that it's going to be flowing this way, plus to minus, because that's what the polarity is going to be. So now we can start at A, and we can go around this way. So we have 36.96 at an angle of 31.54 minus, because we're going, you know, we have starting A, plus this minus this, 10 at an angle of 29 equals. So VTH this way is 26.97 at an angle of 32.48. Could we stop there? Sure we can. But just for fun, we're going to do from A to B this way. So this, we're entering the negative, so it would be negative 11. Or we can just take, and then this is an addition, so we can do 29 at an angle of 10 minus 11.09 at an angle of negative 58.46. And we get, lo and behold, the same thing. So VTH going this way is that. VTH going that way is 26.97 at an angle of 32.48. And that's going this way. So it should work out that way. So did we have to do both sides? No, but we just did it just for fun, just to check. So our VTH for the Thevenin equivalent circuit is 26.97 at an angle of 32.48. Last but not least, we have to do our ZTH. So we have to short this battery, voltage source, and short this voltage source. We'll be putting our I here. So guess what's going to happen? You guessed it. If you haven't already, you should. 600 at negative 90. This is our A to B. And then this is 2K. This is shorted. So if we put our look back method, or if we put a voltage source or whatever, you're going to see 2K is in parallel with that 600 at negative 90. That's our ZTH. So if we put 600 at an angle of negative 90 in parallel with 2K, we'll get our ZTH. Again, we have to use parentheses. So open parentheses, 600 at an angle of negative 90. Close, shift reciprocal. That basically just puts it 1 divided by plus 2K. Do we really need to put this in parentheses? No, I just like to do it. Equals, and then one more shift reciprocal. So our ZTH, ZTH is 574. This is 695, so I'm going to put 70 at an angle of negative 73.30. So that's our ZTH, and we could put that in our Thevenin equivalent circuit, 574.70 at an angle of negative 73.30. Okay, so we have our Thevenin equivalent circuit. Last thing we need to do is get the voltage across the load within this circuit. So we, again, can just use the voltage divider rule. 26.97 at an angle of 32.48 times the load, which is 800 at an angle of 90, divided by 574.70 at an angle of negative 73.30 plus 800 at an angle of 90. So this is our voltage across the load within the Thevenin equivalent circuit. It is, so VRL is 72.10 at an angle of 65.98. And that's the answer we're looking for. All right, have a nice day.